Hello friends, in the previous video we discussed the determination of the adjoint of a second order matrix. In this video we are going to do the same for a third order matrix. Okay, so we have been given a third order matrix and we have to determine its adjoint. Okay, so first we have to determine the minor of each and every element of the matrix. Then we have to determine the cofactor, and then the transpose of the cofactor matrix gives us the adjoint of the matrix. Okay. So first, M11, the minor of the element which is present at the intersection of the first row and first column. So we have to omit this first row and first column and determine the determinant of the remaining, which is 0, 1, 1, 2, okay, which is equal to 0 minus 1, which is equal to minus 1. So M11 is minus 1. Similarly, M12, okay, the element which is present at the intersection of the first row and the second column. Similarly, it is minus 3, 1, minus 1, 2. This is equal to minus 6 minus minus 1. Okay, this is equal to minus 5. Okay, this is M12. Similarly, M13, first row, third column, we have to remove that. So the value is minus 3, 0, minus 1, 1, which is equal to minus 3 minus 0, which is equal to minus 3. Okay, similarly, M21, second row and first column, the determinant is minus 1, 4, 1 and 2. Okay, so this is equal to minus 2 minus 4, which is equal to minus 6. Then M21, second row, first column. Similarly, M22, okay, second row and second column, the determinant is 2, 4 minus 1, 2, 2, 4 minus 1, 2, which is equal to 4 minus minus 4, which is equal to 8. Similarly, M23, second row and third column, second row and third column, so the determinant is 2 minus 1 minus 1, 1, which is equal to 2 minus 1, which is equal to 1. Similarly, we will determine M31, M32 and M33. Okay, so now we'll determine the minors M31, M32 and M33. So M31 will remove the third row and the first column, so the determinant will be minus 1, 4, 0, 1, which is equal to minus 1 minus 0, which is equal to minus 1. M32 is equal to, so the minor of the element A32 is obtained by removing the third row and the second column, so the determinant becomes 2 4 minus 3 1, which is equal to 2 minus 12, which is equal to 14. Similarly, M33, the minor of the element which is present at the intersection of the third row and the third column, so we remove that, so the determinant becomes 2 minus 1 minus 3 0 is equal to 0 minus 3, which is equal to minus 3. So we have obtained the remaining 3 minors, the values of the minors. Okay. M31 is equal to minus 1, M32 is equal to 14, and M33 is equal to minus 3. Now we have to determine the cofactor elements. Now we know that the cofactor of an element which is present at the intersection of the ith row and jth column is given by minus 1 to the power I plus j to m ij, the minor of that corresponding row and column. This is the formula. So we'll apply it. So C11 will be minus 1 to the power 1 plus 1 into M11, which is minus 1. So minus 1 to the power, even it becomes 1, so it is minus 1. C11 is minus 1. Similarly, C12 is equal to minus 1 to the power 1 plus 2 into minus 5. Minus 1 to the power odd is minus 1, so it becomes minus 1 into minus 5, 5. Similarly, C13 is equal to minus 1 to the power 1 plus 3 to minus 3. Minus 1 to the power even is 1, so 1 into minus 3 is minus 3. Similarly, C21 is equal to minus 1 to the power 2 plus 1 into minor, corresponding minor, which is minus 6, so it is minus 1 into minus 6, it becomes 6. Similarly, C22 is equal to minus 1 to the power 2 plus 2 into corresponding minor, which is 8, so it becomes 8. C23 is equal to minus 1 to the power 2 plus 3 into M23, which is 1, which is equal to minus 1. C31 is equal to minus 1 to the power 3 plus 1 into M31, which is minus 1, so it becomes minus 1. C32 is equal to minus 1 to the power 3 plus 2 into M32, which is equal to 14, minus 1 to the power odd, so it becomes minus 14. And finally, the last cofactor element C33 minus 1 to the power 3 plus 3 into M33. M33 is minus 3. So minus 3, which is 1 into minus 3, which is minus 3. So we have determined all the cofactor elements. Now all you have to do is just take its transpose and we'll get the adjoint matrix. Okay. So we have determined all the cofactor elements. So now we have to form the cofactor matrix of A. Okay, which is this: C11, C12, C13, C21, C22, C23, C31, C32 and C33. This is the cofactor matrix of A. Okay. Now the adjoint of A is the transpose of the cofactor matrix, which is equal to the rows become the columns. Okay, the transpose. So it is -1, 5, -3, 6, 8, -1, -1, -14, -3. This is the required adjoint matrix of the given question. The adjoint of A is -1, 6, -1, 5, 8, -14, -3, -1, -3. So this is how we calculate the adjoint of a third order matrix. It's a bit lengthy because the number of elements present is more. So one trick which you can use here, we can directly calculate the cofactor from the minor in case where the number of the I plus j, okay, the ith row and jth column, that sum is even, the minor is equal to the cofactor, and in case where the sum is odd, in that case the cofactor is -1 into the minor. Okay, so in the first case m11, 1 plus 1 is 2, so cofactor and minor, they are the same, the sum is even. But in this case m12, 1 plus 2 is 3, which is odd, so in this case cofactor is 5, which is -1 into -5. So you can use this trick to quickly calculate the cofactors. Here I went into the detailed procedure because you are a beginner into this, so I explained it in detail, otherwise I would have calculated it directly. Okay, so this is how you calculate the transpose of the cofactor matrix for a third order matrix.